All right, so we're about to start our Chapter 11 work, and this is section 11.2, where we're going to start with square roots. I have a couple of facts to remind you of in this first video, and the first one is really just a reminder of what is a square root. And remember that a square root is the inverse operation of raising a number to the second power. That's what that square root is. So we can also think of it as square roots and squaring undo each other. The second thing that I need to remind you of is what are the perfect squares? If you haven't gotten these memorized yet, then you should really know all the way from 1 times 1 all the way through really 25 times 25 would be the ultimate goal, but at least through 20. So I've listed them here for you. I think the first 12 are pretty obvious. There are a couple of little tricks for you along the way. The first is, if you don't know 13 squared, 169, and then 14 squared is 196. Since 14 is larger, the 9 would go first, right? 196. 13 is smaller, so 169. So there's that little trick. And this 16 squared, 256, is one that we see quite a bit. So again, those are going to be memorization, and if you have a hard time with memorization, I would get out the flashcards and get busy on them. The second thing that we need to talk about in this video is the fact that we're no longer given an x of the problem. It just says find the square roots of numbers. So they're just asking you, what's the square root of 81? And since we're not talking about a parabola, we're not talking about a picture, we weren't asked to solve, we're not going to use both the positive and the negative. We're just going to give the symbol to whatever's in front of this square root. So the square root of 81 is, well, 9, because 9 times 9 is 81. And they weren't looking for both answers, they were only looking for the positive answer. In contrast, this third problem, where we have negative the square root of 64, in this problem, they're only looking for the negative answer. So the negative square root of 64 is negative 8. And last but certainly not least is this fourth problem, where we have that plus minus sign. In this problem, they are looking for both answers. So we can just repeat that plus minus. And here's where the beginnings of our next little piece here, that 36 is a perfect square. And 3,600 is made up of 36 times 100. 100 is a perfect square. So I need to take the square root of 36 times the square root of 100. The square root of 36 is 6, and the square root of 100 is 10. So 6 times 10 is 60. So we can work our problems that way. I know we've talked about it, but don't forget about fractions, that whenever we see a fraction, that we can split it into 2 square roots. So we can treat this as the square root of 16 over the square root of 25. And the square root of 16 is 4. The square root of 25 is 5. So that we're looking for the answer of 4/5. Would you please do me a favor and would you finish up these 8 problems? Stop before the next set of directions and check your work. All right, so as you're coming back to check your work, I want to point out a couple of things in this last row. The first is, notice that 29, 34, those are numbers that you're not necessarily familiar with. So if you're using your calculator on those problems, that is a very wise decision. So using that calculator to your benefit is a very good idea. However, hopefully you also saw in this third problem the 289, and you recognized it as being 17 squared, or 17 times 17. But because we have these decimal places, we also need to consider the fact that means that if I have 4 decimal places in this 289, then before I squared it, right, I have to know my multiplication rules. So in order to get 4 decimal places, I needed to do 2 decimal places times 2 decimal places. Again, you can use your calculator, but I wanted to provide you with some information about how this 0.17, right, don't forget the plus minus, 0.17 or 0.17, where it comes from without using your calculator. Because the more you use it, the less familiar you become with this mathematics. Again, the same thing happens here. 576 is 24 squared. One I hope you'll get memorized. 576 has 2 decimal places. Means that my 24 needs to have 1 decimal place. Because when we multiply, we use all of them, or keep a running total of decimal places. All right, let's scroll on down. And what if the answer doesn't come out nicely? As long as the directions say so, you can use your calculator. So if the directions say round, oops. If the directions say round, then you can use your graphing calculator. You can use any calculator to find the square roots. So you just simply put it into your calculator and find those decimal values. And we need to get moving. I don't want this video to be very long, so I'm going to go to the next page, because simplifying square roots is really where the focus of this section is in. We need to cover 2 parts. There will be 2 videos to this. We already talked about simplifying fractions, so remember that when I had the square root of something like 9 over 49 is what this is asking us about. That we take square root of the numerator over the square root of the denominator, and we work them separately. The square root of 9 is 3, and the square root of 49 is 7. We just listed off our perfect square numbers. My suggestion is that you list them all the way from 1 to 25. Pause the video and do that. Your perfect squares all the way from 1 to 25, so you're practicing it. All right, welcome back. Hopefully you wrote down all 25, right, 1 through 25 being squared. There were 5 new ones from the previous side of notes. And now we need to move into, I'm officially taking away, well, not taking away, I'm officially adjusting your calculator and what you're able or allowed to do with it. I know that you're perfectly aware that the square root of 25 is 5, right? Square root of 25 is 5. But with the square root of 50, you're no longer allowed to have a decimal value. If it doesn't say it's okay to round, then you need to assume they want an exact answer. I want an exact answer. To find an exact answer, you need to just simply find the perfect squares and pull them out of the square root, and anything that doesn't have a perfect square gets left inside. Now hopefully that this square root of 50, it feels really familiar to you. Hopefully it feels like the square root of 25 times 2. Well, the square root of 25 is 5. But the square root of 2 isn't exact. We can't just find it. We have to use its decimal value, and we're not allowed to do that anymore either. So we would just simply say the square root of 25 is 5, so that moves outside the radical symbol. And since 2 does not have a perfect square, it stays on the inside. Let's look at another one, 200. Perfect square times a number. Can I find it? Well, hopefully you're seeing 2 times 100. Again, 2 does not have a perfect square, so it's going to get stuck inside. But 100 does have a perfect square, does have a square root that's exact. It's 10 times 10. So we'll take the square root of 100, that's 10, and put it on the outside, times the square root of 2, because that one got stuck inside. Now sometimes when we get to a problem like this fourth one, the square root of 54, sometimes it doesn't stand out as to what that perfect square is. It's not quite as obvious to us. When that happens, you have a couple of different techniques to do this. The first, and the one that I happen to like the best, is to simply take that number that's under the radical, 54, the radicand, and simply just start dividing it, or make its prime factorization. The place I always like to start is with either 2 or 3 or whatever the smallest number is. As long as I start with a prime number, I can do this method. So 2 times 27, and 27 is no longer divisible by 2, but it is divisible by 3. It happens to be 3 times 9. And 9 is divisible by 3 times 3. When we do a factor tree like this, then we can't quite see everything pretty. So what we always say is that if I have a pair of numbers, that would create a perfect square, and I can put one of them on the outside. So a pair of 3's puts a 3 on the outside, and on the inside we were left with a 2 and a 3. So we'll multiply them together on the inside. They don't have a pair. They're not perfect squares. So my answer, and I have to simplify. I can't leave 2 times 3. I have to have a number. So 3 times the square root of 6. This is not the only method to doing this. It's just another way to organize your thoughts. How are you going to figure out what perfect square is trapped under the radical and get it outside and leave its leftovers, the ones that are not perfect squares, on the inside? Let's do 48 together, and then I'll give you a couple to try on your own. So 48. Maybe you see it. I will tell you that 48 is 16 times 3. So the correct answer to this problem is 4 root 3. But you're not practiced at this yet, and once you are, you'll be able to make that leap. But when you're not comfortable, you need to do a factor tree. So 48 is divisible by 2. It's 2 times 24. Then we can divide by 2 again. Remember, these numbers aren't just numbers, but they're prime numbers, right? They only have a factor of 1 in itself. 2 times 12. 12 is 2 times 6. And 6 is 2 times 3. So pairs of prime numbers move to the outside. So I have a pair of 2's on the outside. Now I have a second pair of 2's on the outside. And this 3 didn't have any pairs, so it's left inside or under the radical. Everything on the outside gets multiplied. Everything on the inside would be multiplied. So in this problem, I have 4 square root 3, just like I was expecting. There are 3 problems here for you to try. Then come back and check your work. So you're going back and checking your work here in green. And hopefully in this first problem you saw that 36 times 2. And hopefully you saw here in the second problem that you could have more than one multiplication, right? Hopefully 9 times 2 times 100, you recognize 9 and 100 as perfect squares. And maybe when you got to 750, you didn't really see perfect squares, so you had to do a whole tree. Or maybe you had to do a tree for all 3 of them. Again, it's about what do you understand or what do you see about this. And once you get more comfortable with these, you won't need these trees anymore. We need to talk about a couple of little details with this. And the first is what to do if they've already started the problem for you. There's already a number that's been pulled out of the radical, so we're just going to make sure that it gets tagged along. So that 12, so we have 2 times the square root of, and hopefully 12 being 4 times 3 seems really obvious to you. So we have a pair of 2's already out there. Then we'll have this square root of 4, which is another pair of 2's. So a pair of 2's already out there, times another pair of 2's. And that 3 doesn't have a perfect square, so it gets stuck under the radical. We'll take 2 times 2. That'll give us 4 root 3. All right, let's do this next one. 3 times the square root of, well, this time, and because I want you to memorize it, 48 is 16 times 3. So on the outside, we already have a 3. The square root of 16 is 4. And this 3 that's under the radical does not have a pair, so it's still stuck under there. Outsides times outsides and insides times insides. So 3 times 4 is 12, because it's outside the radical. And the numbers under the radical, well, there's just one of them. It's the square root 3. Let's do Oh, let's see. I'd really like to do the problem right down below here. Outsides times outsides and insides times insides. So that we have 3 times 4. Under the square root, we have 2 times 8. So 3 times 4 is 12. 2 times 8 is 16. And can I take the square root of 16? Yes. So that the square root of 16 is 4. So this really says 12 times 4. And 12 times 4 is 48. All right. I think I'm going to have to put the next part in another separate video.